Assalamualaikum. My name is Aliza Nadira binti Rosli from BMM section 1/2. My matric number is B0919106164. My lecturer's name is Encik Asri bin Din. The topic that I'm going to present are power conservation law, Ohm's law, KCL and KVL. The first topic is power conservation law. Firstly, the basic definition relative to electric power, the power were given that equal by voltage divided by current. The sign of the power indicates whether power is absorbed or generated by the type's elements. If the power is positive, the element is absorbed. If the power is negative, the element is generated. The sign on voltage, current, use the power calculation is based on the current direction and voltage. They must be chosen to the passive sign convention. There are the example circuit we're gonna measure the voltage current for each resistor circuit. Use this measurement to calculate the power of each element and then verify the conservation power. There is sum all the power and always follow the relative sign convention for this resistor by choosing positive current to be entering the positive voltage terminal. Circuit elements. Active is capable of generating electric energy such as generators, batteries, operational amplifier, voltage and current source. Passive elements is incapable of generating electric energy. The example is resistor, inductor and capacitor. Active element is controlled by another voltage or current. They have four different types. First, voltage control voltage source. Second, current control voltage source. Third, voltage control current source. And fourth, current controls current source. Ohm's law. The meaning of voltage is the amount of energy charge move electrons in one point to another in a circuit. It is measured in volts. The off meaning current is the rate of charge flow and measured in amperes. The unit is I and resistance is the opposition of current and measured in ohms. State that the voltage across a resistor is directly proportional to the current flowing through the resistor. The formula Ohm's law is a voltage is current multiplied by resistance. Current is voltage divided by resistance and resistance is voltage divided by current. Two extreme possible values of are short circuit and open circuit. In a circuit analysis, a short circuit is defined as a connection between two nodes that force them to be at the same voltage. In an ideal short circuit, this means there is no resistance and thus no voltage drop across the connection. In real circuits, the result is connection with almost no resistance. In such a case, the current is limited only by the resistance of the rest of the circuit. Open circuit voltage is the difference of electrical potential between two terminals of a device when disconnected from any circuit. There is no external load connected. No external electric current flows between the terminals. Alternatively, the open circuit voltage may be thought of as the voltage that must be applied to a solar cell or a battery to stop the current. Is a measure of the ability of an element to conduct electric current inverse of resistance and the unit is Sims. Series and parallel. Series is the current through each of the components is the same and the voltage across each component. Parallel, the voltage across each of the components is the same and the total current is the sum of the currents through each component. Series circuit in which the current can only flow throughout one path. Current is the same all point in a series circuit. Parallel, there are multiple paths for a current flow. Different paths may contain different current flow. This is also based on current flow. The total resistance will be less than the smallest resistor. Series current, the total current is equal R total is R1 plus R2 plus R3. V total is V1 plus V2 plus V3. In parallel circuit, the total voltage is equal 1 divided by R total. Ohm's law effect in physically system is equal to the cause divided by its position. The effect will be the flow of charge or current produced by the circuit. The cause will be the applied voltage or potential difference introduced, and the oppositions to that flow of charge will be the total resistance of the circuit. KCL and KVL. Relationship between circuit element current and circuit element voltage, and introduce Kirchhoff current law and Kirchhoff voltage law. Node is point in the circuit where two or more electrical elements are connected the specific voltage level with a reference node in a circuit. Branch, the continuous conducting path between two junctions which contains electrical element in a circuit is referred as a branch. Loop is the independent closed path in a circuit that follows the sequence of branches in such a way that it must start and ends with the same node. It shouldn't touch any other junction or node more the ons. Mesh is a loop that doesn't contain any other loop in its interior. Here the two currents entering the node, I1, I2, are all positive in value, and the three currents leaving the node, I3, I4 and I5, are negative in value. Then this means we can also rewrite the equation as I1 plus I2 minus I3 minus I4 minus I5 equal to 0. The term node in electrical circuit generally refers to a connection or junction of two or more current carrying paths or elements such as cable and components. Also for current, the flow either in or out of a node, a closed circuit path must exist. We can use Kirchhoff current law when analyzing parallel circuits. Kirchhoff's second law, the voltage law KVL. Kirchhoff voltage law or KVL states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drop within the same loop, which is also equal to 0. In other words, the algebraic sum of all voltage within the loop must be equal to 0. This idea is by Kirchhoff is known as the conservation of energy. The sum of all the voltage drop around the loop is equal to 0. Starting at any point in the loop, continue in the same direction, noting that the direction of all the voltage drops either positive or negative, and returning back to the same starting point. It is important to maintain the same direction, either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. We can use Kirchhoff voltage law when analyzing series circuits. When analyzing either DC circuits or AC circuit using Kirchhoff circuit law, a number of definitions and terminologies are used to describe the parts of the circuit being analyzed, such as node, paths, branch, loops, and mesh. These terms are used frequently in circuit analysis, so it is important to understand them. The conclusion, it is found that in the series circuit, the current remains the same and the voltage divided according to the load connected. In a series circuit, the Kirchhoff voltage law is applied and the sum of all the voltage is to 0. For the parallel circuit, the voltage remains the same. However, the current divides into the branch. In parallel circuit, Kirchhoff current law is applied. And that's all of me about power conservation law, Ohm's law, KCL and KVL. Thank you and Assalamualaikum.